Okay. All right. So this is in section 4.1. If you're following along, I think it's like on 280, I don't know, 82, something like that. All right. And it's on function composition. 281. Thanks, bud. So function composition. All right. Now, I want to just kind of work with this a little bit to try to set up what function composition is about. Okay, it's a little hokey, but I'm going to work with it. So, you see a lot of people, some of you might have some chickens and you're raising chickens, or you have chickens and they produce eggs and maybe you sell them, right? So, let's say that the eggs that I get, oops, where's my, there it is. Let's say the eggs that I get is based upon the chickens and the number of chickens, right? And let's say that I get about 5.5 eggs per chicken, I don't know, in a month or something like that. I'm not exactly sure. I got this, but I wasn't exactly sure of everything, but I know the basics. So here we go. So C stands for chickens, all right, that you have. Hens, I guess, right? E stands for E of C is the number of eggs. Now I'm going to write a function for the income, and I'm going to base that on the eggs that I get. Okay, and that's equal to $4 times the number of eggs that I get divided by 12. Okay, because it's $4 a dozen. All right, so then I'm taking the number of eggs that I get, divide that by 12, multiply that by 4, and that's how much money I'm going to make from that. It's not profit, right, but it's money. Okay, so I is income, I'm going to say. All right, so here's what I want to do. I'm going to find the income in terms of the number of chickens that I have. Okay, right here I have the income based on the number of eggs that I have, but what I really want to do is base it upon the number of chickens. So the number of eggs, right, which is right, let me move this guy just slightly out of the way, here comes from this function. So then I'm going to take that function, E of C, and I'm going to write it like this, E of C, and then I'm going to divide that by 12 and times that by 4, and there's my function, okay? But E of C is really 5.5 C's over 12, and that's what I'm after, okay? So what we just did there is function composition. All right, so how did that work? Well, let's just do this, okay? Let's say that I have 5 chickens, right, or hens. So I'm going to take 5.5 to find my egg times the number of chickens that I have. All right, so I'm going to go 5.5 times 5. 27.5. So now to find my income based upon the chickens I have, I would take $4 times 27.5 divided by 12. So now I'm going to do that. So I'm going to take 4 times 27.5 divided by 12. And I get 9.16 per chicken. Okay? So what we did was we started with an input, right? Okay? And we ended up with an output, just like a regular function. But what happened was my input went into this function here, and then it took this output and made that the input for this function, which gave me my final output. So it's kind of like what we're doing is taking the input, which gives me an output, but then that output goes back into another function, which spits out an answer. Okay, so that's what function composition is all about. You're taking one function and you're substituting it into another function. Okay, it seems kind of confusing, but that's really what's happening there. So in function composition, if we have two functions, say something like this, okay, and another function, say something like this, I might have had a chat and I didn't get it. I think we're good so far. Let's see here. Okay. All right. So, and we want to take, and let's go like this. Let's go g of f of 3. Now, I like to write them like this. Okay. But your text, and I'm going to double check it here, likes to write it in a different way. And I'm going to make sure that I get the format right. Oh, that's what I thought. They do F. They say it in the beginning. So here's how they would write this. They would write this as G with a little open circle of F with parentheses around that of 3. Okay? So these two things are the same thing. I like this one because the f of 3 is on the inside. So that's telling me, yeah, I know, Sammy, I agree with you. That's telling me that I'm going to do the f function first, because normally we always work from the inside out, right? Inside out. I'm taking my hands. You can't see me, but I'm going inside out. Maybe you can. All right. So I like this form. This one here, I'm kind of starting with the inside guy. I guess I'm starting with the f, but I'm going to take f of 3 first, and then I'm going to take g of whatever that result is. All right. So I'm just going to kind of walk through this. I'm going to go up here first. So I'm going to take 3 and put it into the f function. So 3 is going to go right there. Okay, so that's my input, right? Equals 2 times 3, 6 plus 3 is 9. There's my output. And normally we would be done. But remember, in function composition, this output now becomes the input. And what does it become the input into? The g function. So now we're going to take g of 9 and put that. So we're going to get this pretty big number here, 90. Okay. All right. That's how function composition works. So we started with 3. All right. That's my input, and 90 is the output. Here, it's the same idea. So you're going to do 2, 3 goes in, right? You're going to get 9, and now you're going to take g of 9. It's the same idea, okay? It's just how it's written, okay? So if it's like this, I'm just going to put a number there. Then we would do the f of x first. If it's like this, you would do the g of x first. All right. Which, and see, that's the exact reason why I kind of like to do it this way, because then I know which one I'm going to do first. Okay, I know I'm going to do the g of 2 first because that's inside. All right. Now, what they do is they change it. So when they are talking about this type of thing, they use that notation. But then when they're talking about taking the actual function and substituting it in, then they switch it to this notation. So they kind of switch midstream. I'm not sure why, but that's what they do. So let's do a couple more examples here. All right, so this time I'm going to go and make up a couple of them. So we're going to go here. Let's go with a 2x squared minus 4. And we'll have a g of x be an x plus 1 over 2 and f of x. I kind of like to use my version for the tests and quizzes. But, you know, I'd rather use my version. I think it's only because I think it's easier. Now, if some of you say, convince me of otherwise, then I could change, or maybe I could figure out a way to make it both ways. But I think that the other version is easier. Okay, so let's do the. Okay, thanks. I think it does too. All right, so let's go ahead and do some more of these. All right, so let's go with g of f of -1. Okay. So if we write it like this, which remember would be this way using the book method, all right, we're going to start with f. F's on the inside. We'll work our inside out. So we're going to take -1, put that right into there. Get -8. Okay. Now I'm going to put it into the g function. Okay. See how this input, output. Now this output becomes the input into g. Okay. So g of -8 equals, let's see, g has this x plus 1 over 2. So that's -8 plus 1 over 2, which gives me -7 over 2, or -3.5. Okay. Done. All right. Okay. Now let's do one with h, right? So let's go f of h of 2, I guess. Okay, so remember that would be f, open circle, h of 2. Okay, so which... Carolyn, I don't think there will be any. They're mainly just two functions. It's not that you couldn't have that kind of situation. But mainly I've only seen function composition with two. All right, so what do we do with the 2? Where does it go first? Which function?
It goes into the h first.
Yeah, good. It's going to go into h first, right? So then I go to my h, go up here, and I go, okay, well, oh, h was 2x squared minus 4. So I'm going to go 2x squared minus 4. All right? So now we just work this out. Right? I can put in decimals or whatever. 2 squared, that's 4 times 2. 8 minus 4. So that's 4. Okay. Again, we're done. All right. That's my output. But now I got to take that output and put it into what function? F. Good.
To the f.
Yep. So that becomes the input for f, right? So now we go like this. You say, all right, what's my f function look like? 3x minus 5. Okay. So I'm going to go 3 times 4 minus 5. And there we are. So there's my answer. Okay. Questions on that? And make sure you ask questions. Okay. Don't just sit back and think you got it or whatever. If you got a question, ask, because there's always other people that have the same question. Okay, some of you might be wondering, can Desmos do this? Yes, it can actually. If you define the two functions, f and g, all right, you go f of x equals this and g of x equals whatever the rules are. And then below the lines, you type f of g of 3. It will figure it out. Okay, it will do that. The question then would be, is that more efficient as far as your time? And by the time you get done typing it all in and getting the answer, it's probably not. That would be your call. You'd have to decide. Like that I use it. It has to be in that form. Yeah, good question. F of g of, and then whatever you want to do. It gets that. I don't think there's a symbol for that open circle in that. I'm not sure. I've never done it that way. Okay, so what we're going to do is do a take function composition, just another step, and then I'll give you your little break here. All right, so hang in there for just a little bit longer. So I'm going to change my definitions just a tad bit. Let's see. Let's go with a 1/2. We haven't had a fraction yet. Okay, and g. I'm going to make 4x plus 2. Okay. So now what we're going to do is we're actually going to do function composition, but we're going to actually substitute functions in rather than values in. So what do I mean by that? So we're going to do something like this. So now we don't have a number anymore, right? We have f of g of x. So what is that? Well, it's kind of the same thing. So this g of x here, if I put numbers into that, right, I get numbers out. And those outputs become the inputs into the f function. So this whole thing here becomes the input right there. So then I'm going to get 1/2 times 4x plus 2 minus 4. And then I simplify this. Now, you always want to try to simplify it. There might be a time where it doesn't work out to do that, but in here it does. So we're just going to distribute this. Okay, I get this, and then there's my answer. So f of g of x is equal to 2x minus 3. All right? And that's what you're going to see. Now, in the book, they'll write it like that. Okay? And you always go inside out. Right? Okay. Now, let's do this. Let's flip it. So, in other words, I want to do this. Okay? So, and you might, in case you're wondering or remember, this is called the commutative property. So the commutative property, remember 3 times 2 is 6 and 2 times 3 is 6. So the order doesn't matter in which way you multiply things or add things. It does in other operations, but not multiplication or addition. But let's check it out for function composition. All right, so now I'm going to take the f function and put it into the g. So I'm going to go backwards. So let's see. I'm going to get 4 times. Now I'm going to take 1/2 x minus 4. And then I'm going to put plus 2 here. Okay, so what I did was I took the f function, because I started with the f that's on the inside. I took that, the f, right, and put it into the x into the g. All right, that's where that came from. So I'm going to get 4 times 1/2 x minus 4. And then add 2. All right, let's see if we get the same thing. So this is going to give me a 2x here. This is going to give me a minus 16 plus a 2. You're going right away. You're going, nope. It does not give us the same thing. All right, so function composition is not commutative. It only takes one example to show that it doesn't work, and we just did. So function composition is not commutative. Is there a situation where it is commutative? Yep, there is, but most of the time it's not going to be. Right? There are just certain situations where, yeah, it would be the commutative. All right. So what we're going to do here is we'll take a 10-minute break, come back, and we're going to do more with function composition, and then we're going to move on to 4.2, and that's it. Obviously, we have nothing else to work. We have no quiz because there's nothing to quiz you on. So let's come back. Let's see, it's almost 6:30. Let's just say 6:40. We'll come back and do some more with function composition. So again, don't hesitate. Just ask, ask, ask. The last part of function composition that we want to take a look at is, what about the domains? Is there issues with domains in function composition? Okay, and there is. So if we go back to that chicken and egg thing that I started off with, right? So I said here's E of C was equal to 5.5 C. Okay. Now C, remember, so the C, remember, is the number of chickens, right? Now, so if that's going to be my domain, all right, then what would that domain look like?
Zero to infinity?
Yeah, 0 to infinity, right? So then I could go like this. This goes 0 to infinity like that. Okay. Now, from that particular domain will come a range, right? And what would that range look like?
The same, right? 0 to infinity.
Yeah. Good, Sean. Good. Okay, so then that 0 to infinity, though, now becomes the input for this function, right? So that becomes, okay, so then I think that was E I put there. right? 4 minus the e over 12. So these numbers here, these outputs become the inputs there. So that's almost like that now is the new domain, right? So the new domain for this one is going to be here, as long as we don't have any issues. All right, so, and we don't. I mean, e can be anything there. We're just dividing it by 12, right? So now that domain, right, gives me a new range, which is based upon this. So, and this was times. So what would that range look like?
I think that'd be all real numbers.
Well, if it's all real numbers, then that means now that we're considering negatives. All right, so we're not talking about profit, we're talking about income here. So would it possible for me to have a negative in this situation? Remember,
Yes.
E. Go ahead.
Oh, I was just saying it's possible to be negative, right?
Well, if this is my E values, which come from this domain,
Oh, you're right.
right? So if I put 0 in there for E, that's my smallest one, what am I going to get?
0.
0, right? So look at it, same thing. Okay? Yeah, you're right, Sammy. So there we go. Yeah, you can't have less than 0 eggs. That's right. Okay? So in this situation, we started out with a domain of 0 to infinity. That gave us an output of 0 to infinity, which became my new input. That's my new input, which was also 0 to infinity. And yep, here we go. 0 to infinity for our final answer. Now, again, we're not talking about profit here because obviously we have some costs. You got to feed the chickens, right? So, I mean, then you'd have to purchase them and that kind of thing. But we're not even factoring that in. Okay? So when we're doing domain and ranges for function composition, first of all, we got to look at the initial domain. Okay, what would it be initially? Then we got to look at the new function that we're putting it in, because my outputs now become the inputs there. And is there any values that don't make sense? Excuse me, or things that we cannot have? So we kind of got to check the outputs. All right, from that initial function. We got to check those and make sure there isn't anything that's going to cause us an issue. So let's do some just some hard examples here so that we're going along here. So let's say that let's start off with something like this. Okay, again, I'm keeping them pretty basic, and we're going to go from there. Okay, so here's my two functions I'm going to deal with. All right. And I'm going to go with g of f of x. I'm still doing function composition. Now, we're not talking about numbers anymore. Okay, we've transitioned away from that. And we're looking at pure function composition. So we're going to start with the f, right? F is going to go into g. So let's do the composition first, and then we'll talk about the domain. So I'm going to take this thing, put it in there. All right. So I got to put this whole thing into that x. Now remember I said, hey, it's a good idea. Simplify this out. So you should write it twice, do some foiling there. I'm just going to do this. I always tell my high school, hey, if you see that, write it twice. Write it twice. Okay, I don't know if your instructors told you that. And then FOIL. Okay, almost everybody knows how to FOIL. So that's 6 and 6, that's 12. Put a square there. And put a plus 9. Plus this 1. Okay, so this 9 is going to give me a 1. I'm just going to put that 10 on there and call it good. Alright, so there's my deal. Alright. Now, let's go back and look at the domains. Okay, first we got to look at this domain. So I'm just going to start off here with this. Let's look at this domain. What's the domain of that?
numbers.
Yep, all real numbers, right? So I'm just going to go like this, all reals, okay? So then I'm going to put all those numbers in there, right? All these real numbers are going to go into that 2x minus 3. It's going to spit out what? What's it going to tell me? What's the range for that? Yeah, it's all reals. Good, sweet, Carolyn, good job. So that's all reals, okay? Now those outputs become my inputs, right? So I really want to check this thing now. And I want to go, man, that x squared plus 1. Is there anything that I can put in there for x that's going to give me a problem? Because if there is, then I got to fix it. All right, so what's the domain for this thing going to be? That parabola.
All real numbers.
All real numbers, right? So I'm not going to have any issues. That's great. So then my domain for this whole thing is all real numbers, because I didn't have any issues in the beginning, and I don't have any issues in that function. Now, what do I know what the range is? Well, you know what? You got to graph it to find out, because we don't know what the range is. All right, there's just, I mean, if it's all real numbers for domain, we'd be sitting here picking numbers all day. All right, so you have to go ahead and graph it and see what the range of that is. It doesn't always going to be, it's not always going to be all real numbers for the range for that, because it's going to bottom out someplace. The range isn't all real numbers. The domain is all real numbers for this. Okay. Yeah, I don't know where you guys have to graph it, see exactly where it bottoms out, right? What the minimum is. I'm putting it in now here.
The range would be 1 to infinity.
Yep, that's what I got too.
Yeah, right. Because if you put 0 in, it just leaves a 1. So.
Okay. So there's my range, right? But the main thing was, this is where we started. Looked at the outputs, didn't have any issues with what we're putting into that g function. We're ready to go. All right. That's how that works. Okay. Now let's whip it up a little bit. And let's do one like this. Okay. So now I'm going to go with g of f of x. Okay. So which function's going into which? Which function goes into which? F goes into...
F is going to go into G.
Yep, great. F is going to go into G. Yeah, it's getting recorded, Sammy. I'm pretty dang sure I started it. Yeah, it's getting recorded. If you got a question, ask, okay? Don't... I mean, that's all right. Just ask away. So, F's going to go into G, all right? So I'm going to take this. I'm not even worried about domains right now. I'm going to put that into there. Oops. I'm going to say, okay, I'm going to figure this out. So I'm going to put this here. I'm going to put this into that x, right? Minus 1. And there's my answer. Okay, there's my g of f of x. All right, now let's talk about the domains. Okay? So first thing I do is I go to the f function. Why? Because that's what's getting put into the g. All right, so I'm starting on the inside. Okay, so I'm going to come over here. I'm going to write down here. What's the domain of that?
-3 to infinity.
Hold it. Now I'm not saying this. Okay, I'm saying this.
Oh. Okay.
You start with the f. Okay, what's your domain for f?
It's all real numbers.
It's all real numbers. So there's no limitations. We're solid. All right, now what I'm going to do is take a look at this function. Okay, and I got to ask myself, all right, now do I have any limitations with the square root? Is there anything that a square root cannot be?
Cannot be negative.
That's right. So then that number underneath that square root, I want to change this to gold here. Right. This x minus 1 has to be a positive number. It has to be, well, it has to be 0. Greater than or equal to 0 in order to work. So what that means is that this x plus 4, okay, that x plus 4 minus 1, this whole thing, has to be greater than or equal to 0. In other words, x plus 4 has to be greater than or equal to 1. Okay, because 1 minus 1 is 0. And if I have 1 minus 1, that's 0. I can do that. And anything greater than 1.5 is okay, because 1.5, or excuse me, 1 is okay. 1.5 minus 1 is 0.5. So anything greater than 1 is okay. So I'm going to go ahead and go like this, and go like this, and now I have this. Okay? So my domain now is x is greater than or equal to 3. So the domain for this one is x is greater than or equal to 3. You say, well, didn't you ignore the thing up here? Yeah, well, I did not ignore it. It's just that it's all real numbers. But the numbers that I get out of there, okay, they got to be greater than or equal to 1. All right, they got to be. And the only way that's going to happen is if I restrict that to just be greater than or equal to 3. And then that works. Okay? -3, sorry. It's -3. My bad. It's -3. So as soon as I get greater than or equal to -3, I'm okay. But because of that g function, I had to toss out all those other numbers. Okay? But you always start with the one on the inside. Okay, what about the domain of that? What is that? Okay, now what about what is the domain for g, or the function that we're taking last? All right, what's the situation with that? It's a little tricky.
I have a question real quick.
Yeah.
It might be a silly question, but
no such thing.
Just because I'm not understanding this at all. So essentially what we're doing is we're finding the domain of the f function, and then we're finding the domain of whatever f of g of x is. Does that make sense?
Yes. So Sammy, think about, again, if we go back to that egg and chicken deal, right? So I started out with the egg where I have a domain, and the domain is was greater than or equal to 0. Okay, because I can't have any negatives. All right, so I got those, but then I got an output out of that. Okay, mm-hmm. And then that output became the input for that new function.
Okay.
Which also had to be positive numbers, right? I couldn't have any negatives. So that's what we're doing here. We're saying, all right, it's not just f, all right, it's what's on the inside. So if I do something like this, I don't know what h is and I don't know what f is, I need to find the domain of that first.
Okay.
Okay. And then that domain, if there's no issues, then maybe it's all real numbers. Okay. But then I got to check and see, well, what about this guy? Because if there's some problems that arise, maybe I can't take this, maybe it's a square root and I can't have a negative, then that means I have to change the domain of this so that my outputs don't cause an issue when they are the inputs for that f.
Now, when you're saying issue, could you give an example of what an issue would be with this?
Sure. So let's go back here. Let's just make some of these up. So let's say we have h of x is 1 over x plus 1. Okay. And let's say that f of x equals 1/2 x minus 2. All right. So let's do this one first. We'll do both ways, so you'll see it both ways. All right, so we're gonna do this one first. Again, I'm not too concerned about doing the domain first. All right, I'm gonna take this h function, slide that in there. So I get this. See how I'm putting parentheses around this thing? Okay, minus 2. Now, this might be a good situation where I probably, I mean, you could multiply the 1/2 in there. So if you did, you get this. Now you have to take that to both of those. But that's as much as you're going to simplify that. Okay? So it looks pretty complicated. But that's our answer. But what about the domain? Okay, so I'm going to go back to the h function first because that's the one I started with. Okay, here's my h function. Are there any numbers there? Or let's just talk about the domain. What's the domain of that h function? Anybody can answer here. Help do it all. Yeah, we can't have a -1. Why not? Makes the denominator 0. We can't have, it's right, we can't divide by 0, right? Good job. Okay, we can't divide by 0, so that means that x cannot be -1. No matter what happens, x can't be -1. So that domain occurs right away. All right? Now, the next thing I do is I check this function. Okay, because that's what the h is getting substituted into. And now I got to ask, hey, that is a 1/2 x minus 2. What's the domain of that? Yeah. What's the domain of that 1/2 x minus 2? That's going to be all real numbers. Okay? It's a line. All right? All lines have all real numbers. Okay? It's all real numbers. So then we don't have any problems there because it's just all real numbers. So what does that mean? That means that my domain down here is going to be x cannot be -1. Okay? X cannot be -1 because if it is, then I got a problem writing it initially. But in here, I'm okay. Now look what happens. If I put -1 in there, right, I get -1 times 2 is -2 plus 2 gives me 0, and I can't have 0 on the bottom. Okay? Now let's flip it. What do I mean by that? Let's change the order. So now we're going to go with f into h. Okay, so then I get 1 over 1/2 x minus 2 plus 1. So I'm going to get this. And this, I'm just going to combine these two. 1/2 x minus 1. So that's what I get. Okay, again, it's kind of messy looking. All right. So now I'm going to go back and talk about the domain. And I want to talk about the domain of the f function first because that's the one that I started with. So I go back up to that f function. What's the domain of that? What's the domain of the f?
All real?
Yeah, it's all real. Very good. Okay, so you're feeling pretty good about that. So now, well, we got to talk about the h, right? Because that's where those all real numbers are getting put into. Okay, so I got to make sure that the h function can handle that, right? I got to make sure that, hey, can it handle all real numbers? No, it can't, because when x is -1, I got a problem. So that means I have to go back to my f function and I have to set it equal to -1 to find out, hey, what x value is giving me that output. So I'm going to just work this out. And there it is. So x cannot be 2. Right? So that's that domain. And sure enough, if I put 2 into here, look at that. I'm going to get 0 on the bottom. Can't have that. Okay? And that's how it works.
Okay, this is all starting to make sense.
Oh, that's good. You just gotta buy into that. The input gives me an output, but that output now becomes the input into my new function. Okay? And that's where you got to watch your domain. It's not just necessarily in the beginning, but it's also that intermediate step where that range becomes the new input or the new domain. Okay? And the range here, we just have to graph it. Okay? We just have to type that in. There's no way to find in the range. You just got to graph it. Okay, but I don't think they ever ask you about that. I'm pretty sure they just ask what the domain stuff. Yeah, they don't ask about ranges. Okay, they don't ask. I'm looking to see which ones. Here, let's do this one's really tricky. Well, we don't have to do this one. It's not in our assignment, but let's look at it anyway. All right, so let's take a look at this one. All right, so now we got basically two rationals. Okay, and that's why I didn't give it to you, because I don't like to give you too many rational ones. I think I gave you one, but anyway. So let's look at this one, right? So we're going to do f of g of x. Okay, so I'm going to take the g function, put it into there. So I get 2 over x, oh my goodness, over 2 over x plus 3. Now really, there isn't a whole lot I can do to that. You can simplify the bottom and then simplify it again. But I don't really know if that makes it any better. What we would do is find a common denominator. All right. When I add fractions, I got to have a common denominator. So I better multiply this by x over x. So I get 2 over x plus 3 over x. All right. And that's going to give me 5 over x. All right, now this thing here, this is kind of weird. I think we should just leave it, because it's gonna just it's just gonna cancel out. Okay, so let's just leave it. All right, so there's what I got. Okay, so it's kind of a mess. So I took the g function, okay, and I substituted it in to the f, and I got this mess. All right, so I'm going to start with my g. All right, I'm going to write down, okay, what's the domain for the g? So can someone go ahead and tell me what's the domain for the g function?
If x can't be 0.
Yep. X cannot be 0. Okay, good. Anything but 0. Good. Okay, can't have a 0 on the bottom of that fraction. All right, so x cannot be 0. So right away, we have a restriction or a limitation. Okay, so I did the g. Now I'm going to work at the f, right? Because the outputs from g become the inputs for f. So now I got to look at this, and I got to say, okay, what about my domain for that? What can't x be for that function? X can't be -3. Okay? But remember, these are the inputs that come from the outputs of this. So then what I got to do is come over here and say, okay, I want to solve that equation. I got to figure out when is 2 over x going to be -3, because when it is, I got to toss that number. I can't have that. All right, so I'm going to do a little cross multiplication here and divide by -3. So when x is 2/3 negative, we got a problem. Okay? It can't be that number. But also, it can't be that number. So here we kind of got a double thing going on here. So that means that my domain for the whole thing, x cannot be 0, x cannot be a -2/3. So it can't be 0 because that gives me a problem in the first function. And it can't be -2/3 because that gives me an issue right from the beginning. No, -3 is okay. Because see, if I put -3 in here or put -3 in here, I'm okay. All right. The output couldn't be -3. So where did that output come from? Well, that output of -3 comes from when x is -2/3. Okay. Yep. Then if I put those guys into my crazy function that I have up here, it ain't gonna work, right? X is 0 is not gonna work there. 0 is not gonna work there. It's gonna cause me an issue. -2/3 is fine on the top, but -2/3 here on the bottom, when I do some simplification, isn't gonna work. Okay, it just isn't gonna work. So yeah, function composition, not too bad, but when you start talking about domains, that makes it a little bit more complicated. Okay. Questions on that? I mean, like, 32 would be something that I only gave you like one of them, so, and I wouldn't put one of those on a test where you have to check it twice. At least I don't think I do. There'll probably be a couple things on there. When they ask you to do this, you go, what? Yeah, you're actually taking the f function and putting it into the f function, okay? It doesn't make a lot of sense, but it is something that they ask you to do. So that's what you're doing. Just take the f function, whatever the heck f is. Okay, so if f is 2x minus 3, then you take 2x minus 3 and put it in. So you have this, wherever there's an x. Okay, put it in there and just work it out. That's all you do. All right. Okay. Let's talk about inverses. Not as bad. Let me change to a blue here. To talk about inverses, yeah, this is 4.2. To talk about inverses, I'm actually going to have you explore a little something here. So I'm going to stop sharing for a minute and show you where this thing is. So you want to go to, maybe I can put it into the chat. Where is it at? It is in, there it is. So go to the course home, content, all right, and then check out week 4, which is on the left, okay, and then you'll see something called function inverse, and it's a GeoGebra document, okay, so go check that out. So we're going to course home, all right, content, week 4, function inverse. So go ahead and go to that. So when you get there, all right, when you get there, I basically just, there's some little tiny triangle like arrowy things on the bottom. Oh, hit the reflect first. So I'm going to put this in here. So when you get there, click on reflect f of x on / off. And then slide blue arrows on the, or below the graph. Okay. I just want you to basically play around with that for about a minute or so. Okay. So hopefully you got a chance to play with that just a little tiny bit. All right. So let's see what's happening here. How is the green graph related to the blue graph? Can someone give me some ideas on that? How are they related? Nice. Getting some great answers. We got to turn 90 degrees. Same vertex. Like it. Any other ideas? Mine is just shrinking. Okay. Yeah, it should. All right. So let's take a look at this all together. So I'm going to turn this off for right now and this off. All right. Okay. So I started off with this blue parabola here, and then I did a reflection. Okay. So some of you said that the green graph is a 90-degree rotation of the blue graph, which it very well looks like. Okay. But I want to show these corresponding points here. So I'm going to take this red point, I want to slide it. along this graph like this. And do you still think it's a rotation, or is something else happening there?
It's the opposite.
What do you mean it's the opposite?
I guess I shouldn't say the opposite, but
So this point here, there is a reflection. You're absolutely correct. This point here has a reflection over here. All right. So all these points are being reflected. All right. What we thought was a rotation isn't. It's a reflection instead. See, if I turn this off, reflect, there it is. All right. So the green graph is a reflection of the blue. Over what line is that a reflection of? Which line is it reflecting over? X-axis? Does everybody else think that? I like the thought. The dotted line. Okay. The dotted or dashed line. Yeah, that's what it's being reflected over. Okay. That's what it's being reflected over. Now, so the green graph is what we would say the inverse of the blue graph. All right, so if I take this off, I don't do the reflection, there's my blue graph. Now the green one is showing me this is a reflection. Okay, so, or the inverse, sorry. The green is the reflection over this line, but it's also the inverse. However, if I take this vertical line and I slide it along there, what can you tell me about the green graph?
that it's not a function.
Yep, the green one is not a function. Okay. So in this case, when I have this blue parabola here, and I find the inverse is not a function. And that gives us an issue, okay, because we want our inverses to be functions. So then what we have to do is we have to fix it. Well, how do we fix it? Well, what we're going to do is we're going to change so that this looks like that. And now it is a function. Okay. But let me see if I'll do it. Oh, no, I won't. In order to make that work, okay, in order to make that work, I don't want that. I have to change this so that the blue one reflects only that part, which means that this would have to go away. Okay, this blue part here would have to go away, and I can only have this part. So I'm taking the domain of the blue one and I'm changing it. Okay, and I'm changing it. We call that restricting the domain. So that's a lot about inverses. Okay, but we're going to come back to this graph here in a little bit. So I'm going to stop this share. And here we go. Let's go back into this. And I'm hoping that I'm still recording. Yes, okay. So here's what we did. So we took a graph, a blue one, which was f of x equals x squared. And we said, okay, we're going to we're going to reflect that over this line, which, by the way, is y equals x. Okay? That's what line that is. It's y equals x. It goes right down the middle. And now we're going to do a reflection so that it looks like this. So the inverse is always a reflection. An inverse of a function and I'm just going to call this f with a little -1 like a power. That's the symbol for that. Okay, the inverse of a function f inverse of x is a reflection of f of x over y equals x. Okay, so the inverse of a function f of negative x is a reflection of f of x over y equals x. So the inverse and the functions are reflections of each other. That's what that's trying to say. F inverse of x is how you say it with a little -1. You don't say -1 at all. You just say f inverse. The -1 means the inverse. Okay. With a little closer investigation here, I'm actually going to do this. I'm going to go y equals x squared. Okay, and I'm going to do this. All right. And I don't really care if you write this down or not, to be honest, this part anyway. Okay. And I'm going to go like this, and like this. And I'm going to graph this. So 0, 0, 1, 1, 2, 4. So there's my parabola heading up that way. Okay, 3, 9, so forth. Now, I have this little reflection line going through here, like this. Okay, which reflects it. Okay, so like it was said, and I know who said it, but I don't want I'd be butchering your name if I said first name, and I apologize for that. Ezekiel, I think it was, said that 0, 0 and that are the same. So they both have the same vertex, right? Okay, that's true. But then it starts to come up and it flattens out, right? Almost in the same way that the blue one is getting steeper. So 1, 1 is a point on there. Okay, even though I have it, it's really like that because you both 1, 1's there. But 2, 4 becomes 4, 2. Okay, and 3, 9 becomes 9, 3. So the x's and the y's switch. And that's an important idea in inverses, that the domain and range switch. For f primes of x and f of x. They switch. Okay, so the domain and the range switch. And too bad it doesn't show me in that GeoGebra thing, and if I played around with it enough, I could probably get it to the coordinates of those corresponding points, and you would see that they do switch. Okay, it's just not going to take my word for it. They switch. All right, and that helps us find inverses. Okay, That idea is what we use to find inverses. So if we have a function and my goal is to find the inverse of x, okay? I'm going to find the inverse of x. So here's how we do that. First thing you do is you set f of x equal to y. That's the first thing you do. Always set it equal to y. All right. Now, here's where we're going to use that idea. The domain and the range switch. So x becomes 2y plus 3. The domain and the range switch. Now what I'm going to do is solve for y. All right. So I'm going to subtract 3 and divide by 2. So there it is. F inverse of x is equal to x minus 3 over 2. So if we graph these two things in Desmos, and let me just show it to you, and then I'll come back to this. So let me get rid of this, and see if I can, oh, I can just shove that. Oh, it's right in the way. Well, I guess it's all right. I don't think you're seeing this anyway. There we go. So what do we have? 2x, maybe I put a y equals in front of that. Let's see, 2x plus 3. Okay. Now I'm going to put the inverse in there. Y equals, let's see, we had x minus 3 over 2. So I'm going to put that in parentheses, x minus 3 divided by 2. And there it is. Now we put this one in, y equals x. So you get the whole thing, okay? All right, there it is. And sure enough, those are inverses of each other. Okay. So there's that point. And the domain and the range are switching. I don't know if you can see that. But they are. They're switching. Okay. All right, so let's try another one. All right, let's try another one. So let's go f of x equal to negative 1/2 x plus 4. We want to find the inverse of x. All right, first thing, always set it equal to y. Always set it equal to y. Switch them. All right, switch them. Now I solve for y. Okay, so now I solve for y. Now what I'm going to do is just multiply by 2. You could divide by negative 1/2 if you wanted to. It's going to be the same thing. So I get negative 2x plus 8 equals y, and there's my inverse. And again, if you graph those, you'll see their reflections. Okay. Okay, so hang in there, we're almost done. I want to do this one now. No. That's a good question. So, not in all situations will that work. Okay, so that's why I was really hesitant to say that. Those are like reciprocal functions and not necessarily inverse functions. Now, that could work in certain situations, but not all the time. Okay. Like, well, you can look at this one, for example, if you want. Here, let's do this. Okay, so I have f of x equals x minus 1, right? So I'm going to set it equal to y. And switch the x's and y's. Okay. And now we're going to solve for y. Okay, so then we got to look at this and go, what? Solve for what? How? What are we going to do? Well, we got to square. So we're going to have to square root both sides. And then add 1. So see, that's not, so if you put 1 over, what do we have? Parentheses x squared minus 1, you're not going to enter, that square root's not going to show up. Okay? Does that make sense? Or answer your question?
Yeah, sorry, I'm writing.
No problem. Okay. So what I'm going to do is stop sharing this and share this. Oh, it didn't disappear, did it? All right. Oh, let's see, where's it at? There we go. Okay, so I'm going to go into here and I'm going to type in that little deal I just had. X minus 1, I think it was, squared. Okay, enter. So now it gives me this. Okay, I'm going to reflect this. Okay, what can you tell me about the green function or the green graph? What's going on with the green graph?
It's not a function.
That's right, it's not a function. Okay, so we have to change it so that it is. Now it is. Okay, and I'm trying to get it to be exact, but I'm not going to. So as soon as I make this value 1, I'm okay. All right, but that means I have to restrict this guy, the blue one. So the blue one, the domain of that has to be x is greater than or equal to 1. Okay, in order for that to work. I don't know. I used to be able to do it, but I can't understand why It won't let me try this, refreshing it maybe. No, anyhow. No. I thought it did, but I thought it did bring the blue ones down at the same time. Oops, let me go back to that one. There we go, reflect. So anyhow, I have to get it so that this blue one here is right at 1. I can't have anything over here in the negative parts, basically. Okay. Now, there's an easy way to determine when that's going to happen, right? Because you're basically going to tell me, well, the vertical line test tells me that that's not a function. Oh, yeah, you're right. But look at this. The horizontal line test will tell me if f will give me an inverse, that's a function or not. Okay, so if I have here, look, I got 2 points that this horizontal line touches, right? So that means that this green graph is not going to be a function. But if I slide this down to right there, okay, just barely at 1, you can see I still got a couple dots there, but I don't think I can get it to be any different. Okay, as soon as I get that to be at 1, all right, then I'm going to have a function. Okay, that's as close as I can get it. And that's why I want to restrict it. Okay, so the horizontal line test will always tell me if f will have an inverse or not. That's a function. Okay, use the horizontal line test. And it kind of makes sense because some of you said, well, don't I just rotate that? So even though we said it wasn't a rotation, it was a reflection, right? It kind of works for the vertical line test. Okay, so if the vertical line test doesn't tell me, or if vertical line tests tell me whether the inverse isn't a function or not, then a horizontal line test is going to tell me whether the f is going to give me a function or not. And that's what I wanted to show you, okay? So if the horizontal line test, which is the same as the vertical, horizontal line test, so if a horizontal line intersects, touches, passes through, put in whatever you want, intersects f of x in more than one spot, and more...
I can't see what you're...
Oh, thanks, you're right, you probably can't. Gosh, dang it. There we go. Thank you. In more than one point, then f inverse of x is not a function. That's what the horizontal line test says. So if a horizontal line intersects f of x in more than one point, then the inverse is not a function. And you have to restrict that domain, okay? So you would have to take this parabola here and chop that part off so that that domain is greater than or equal to 0, assuming that this is y equals x squared. Okay, so that green one is going to look like that. Okay, and that's it. So that's what that horizontal line test was about. All right. I'm just looking at some of your problems here on here, and they're going to ask you to find some inverses. Okay. Remember domain and range switch, because they give you some with some just domain and ranges, so you're just going to switch them. Okay. Here on problems 35 through 38, they're going to ask you to do some function composition. Okay. So let's say that we have something like this. And it says, can you show that f of g of x is equal to x? And please show that g of f of x, they don't say please, equals x. So then what you're going to do is just do the compositions of those, right? So g is going to go into f right here. So my g, that's this, is going to go into f. So here we go. So I'm going to take the cube root of x plus 8. And don't let the cube mess you up. It's not a big deal. Minus 8. So the cube root, I'm basically going to cube that. So they just kind of cancel out. And we're left with x plus 8 minus 8, which is x. Okay? Here, I'm going to do the same thing. So I'm going to put f into g. So I'm going to take the cube root of x cubed minus 8 plus 8. Well, the 8's are going to go. Cube root of a cube is just going to give me x. And that's what they're going to ask you to do, is just show that those things are the same. When that happens, they're inverses. Okay? So when you do the composition and they turn out to be x, they're inverses. I should go back up and tell you this. A function that passes that horizontal line test is 1-to-1. So if f of x passes, meaning that it works, horizontal line test, then it's 1-to-1, which means there's 1x for every 1y. Okay. That's all there is on here. Okay. I think you can work through the rest. And if you can't, you can always ask questions on Wednesday, because I feel like we've gone enough. So that is everything from that.
1 and 2.